All right, we're going to start in on chapter 2 here. So we're doing 2.0, 2.1, 2.2, and then 2.5, and then 3.1 and 3.2 are going to be what the next test is going to cover. Okay? Um, so let's see, problem 1. I have some equations we're going to solve for x. In the first equation, now the idea with an equation is to get x on one side and all the other numbers on the other side. So like with this equation here, let's go ahead and add 2x and subtract 29. Okay, negative 6x plus 2x is negative 4x. And then when I subtract 29, 5 minus 29 is negative 24. And then divide by negative 4. Negative 24 over negative 4 is 6. Okay, so the answer there would be 6. Okay, now you can check your answers if you want to or not. It doesn't matter. Okay. A little bit later, we're going to see some equations that you have to check your answers with. Yeah, these you don't have to do that. Okay. So let's see, the next one, part B, I got 7 times x plus 1 equal 4 minus 2 times 7x plus 5. Solve for x. Okay, let's distribute 7 on the left and then the negative 2 on the right. So we have 7x plus 7 equals 4 minus 14x, and then negative 2 times 5 is negative 10 at the end. 4 minus 10 is negative 6. Okay, and then let me go ahead and add 14x and then subtract 7 from both sides. Okay, 7x plus 14x will be 21x on the left, and then we're subtracting 7 from both sides. Negative 6 minus 7 is negative 13 on the right. Divide by 21. So it looks like x is negative 13 over 21. That'd be the answer. And like if you're just solving an equation, give me the exact answers. Okay, so like there's no reason to go to the calculator and type this in. So just keep all the answers in exact form for me. Part C. We want to solve the equation 3/4 plus x over 5 minus 1/2 equals 4x over 5. Okay, so with this one, let's go ahead and get rid of these fractions. I don't like working with fractions, right? So if I begin by multiplying both sides of this equation by the common denominator of all these denominators, that'd be 20. Right, so 20 is the smallest number that all three of these numbers go into evenly. Then we should get rid of the fractions. Okay, so we're going to multiply both sides of this by 20. 20 times 3/4, so 20 divided by 4 is 5, and 5 times 3 is 15. 20 divided by 5 is 4, times x is 4x, minus 20 over 2 is 10. Okay, and that's equal to 20 over 5 is 4. 4 times 4x is 16x. So then I'm subtracting 4x from both sides. And then 15 minus 10 is 5. And then we're subtracting 4x. So 16x minus 4x is 12x. And then divide by 12 there. So x would be 5 over 12, that'd be the answer. Okay, here's another one. So now I chose to get rid of the fractions right away. You don't need to do that. It's just you're working with fractions then throughout the whole calculation, which makes it more difficult. But so usually whenever we have fractions in an equation, we try to get rid of the fractional form there. Okay. Okay, let's go ahead and multiply both sides of this equation by 15. 15 is the smallest number both 5 and 3 go into evenly. And 15 divided by 5 is 3. So then 3 times 3x minus 1, that'd be 9x minus 3. I'm bringing the 15 into both these terms. 15 times 2 is 30, so minus 30 equals 15 divided by 3 is 5. 5 times 2 minus x, that'd be 10 minus 5x. Okay, and then we're going to add 5x to both sides. 9x plus 5x is 14x. Negative 3 minus 33 is, negative 3 minus 30 is minus 33. And when I add 33 to both sides there, 10 plus 33 is 43 on the right. Divide by 14 there, so x would be 43 over 14. That's the exact answer there. Okay. Problem 2, we want to solve this equation for x. Right now it's solved for y. But so if I get x all alone here, let's distribute 3 on the right. So I got 3x minus 6 plus x. 3x plus x is 4x. And then if I add 6, I got y plus 6 on the left. And then we're solving for x, so divide by 4 on both sides. X would be all alone then. X is equal to 1/4 times y plus 6. That'd be the answer. Okay. Problem 3. Write each answer using set builder notation and then using interval notation. Okay, so I mentioned this in the last chapter that set notation and interval notation will come up a lot. We have to be familiar with both kinds of notation. We're going to see both kinds all over the place there. So in part A, if I had all the numbers that are between 3 and 17, including 3, using set builder notation, I would just tack on a set of all x such that 3 is less than or equal to x is less than 17. Okay, and then using interval notation, order matters. Smaller number first, bigger number second. So I got 3 comma 17. There's going to be a bracket by 3, right? Because we're including 3. We're not including 17. So I'd want a parentheses by 17 there. In part B of this, we have x, where x is less than or equal to -7, or x is bigger than 1/2. So as a set, I would just say the set of all x such that x is less than or equal to -7, or x is bigger than 1/2. Now, I mentioned this already, but it is worth saying again that whenever you have a statement involving the word or has to stay there. Okay, in your answer there. Okay, so like I would not write this down. I wouldn't write like x is less than or equal to -7. Right. Also, x is bigger than 1/2. Like I can't write it as a compound inequality or as a 3-part inequality here, because what I'm saying doesn't make sense. Right? You're saying that -7 is bigger than 1/2. Is that true? No. -7 is not bigger than 1/2. So something like that doesn't make sense to anybody. Okay? So, again, when the word or is being used, you have to keep the word or. Okay? Now, on the problems that are on the computer there, you might see the union sign. The union sign takes the place of the word or. Okay, so you can use that if you want. Or is only 2 letters, right? So you're not saving a ton of time by using that symbol. But like in some of the problems, like they'll want you to give the answer using the union sign. Okay, so that would be the answer as a set. As an interval, Anything less than -7 means you're heading out towards negative infinity. So I got negative infinity to -7. There's going to be a bracket by -7, right? Because we're including -7. And you're not including 1/2, so, or 1/2 to infinity, parentheses at both ends. Okay? Again, smaller number first, bigger number second. Okay? Whenever you're writing down an interval. So, okay, we'll go ahead and stop the video right there, and we'll pick up with problem 4 in the next one there. Okay.